In this video, we are going to learn about electric potential. But before we move ahead, let's do a little bit of recap what we have learned before. Remembered I equal to Q by T? What is the meaning of that? The amount of current I depends on how much charge moves in a certain period of time through a metallic conductor. Okay, now let's do a brain teaser. How many electrons flow through a phone charger in 1 minute if the current passing through it is 0.04 ampere? Once again, let's read the question nicely to understand it better. How many electrons flow through a phone charger in 1 minute if the current passing through it is 0.04 ampere? Okay, take some time, do this mathematics and answer me in the comment section. And let's move on to our today's topic, that is electric potential. Well, we all know that the electrons love to move. But have you ever asked what makes them move? It's the voltage that makes the electron move. So let us now understand what is voltage. Voltage can be also called as electric potential. You can also call it as electrostatic potential or just potential. Now, the word potential is quite familiar. Remembered potential energy? If there is a hill and a ball is on the ground, so it has zero potential energy. That is very low potential. And if there is another ball elevated to the top of the hill, then it has a high potential. It gains potential energy when it reaches a height. So the ground ball has lower potential. The ball at a height has higher potential. As we move to a height, we gain higher potential energy. But the ball will not remain there forever. It's not possible. The ball will try to roll down and come back to the ground. So higher potential has a tendency to drop towards lower potential. Another example we had done while explaining current. So there was two containers. One contained blue liquid, which was at the bottom of the container. Another had a pink liquid. And if we connect the two containers with a pipe, what would happen? The liquids would start flowing from the pink part to the blue part. And they will flow unless the two parts have equal heights. Now same for the electrons and the charged particles in the metal plates. This metal plate has lesser electron and this one has more electrons. If we connect a conductor, if we connect the two plates with a metallic wire, so what happens in that case? Now there's a difference in their electric potential. Just like the potential energy, gravitational potential, this is called electric potential. And through the conductor, the electrons tend to move from the metal plate with a larger number of electrons to the metal plate with a smaller number of electrons. So there's a difference between the two potentials, and that is called potential difference. Now, let's say there is a charged particle that may be an electron and that is negatively charged. There is another electron which is positively charged. It's not an electron, it may be some proton or other kind of positively charged particles. Now let's take a third particle. This is also a positively charged particle. Now we know negatively charged particles attract positively charged particles. But here's the thing. This is our negatively charged particle, that is the electron. Now this electron has a field around it. It has a region around it. So if we draw an imaginary line to indicate its region, this region is called the electric field. What does that mean? That this electron can attract this proton. Okay, this proton will come towards it. But however the electron tries to attract this proton, it will not come. Why? Because the electron does not have the potential to bring it towards it. It is out of its field. It is far away from it. The electrons does not have so much energy that it will pull it. So this is out of the electric field and this was inside the electric field, so it has pulled it. So this is called an electric field, and that charged particle is not in the electric field for this electron. Now, the electric potential at a point in an electric field is defined as the amount of work done in bringing a unit positive charge from infinity to that point. The electric potential at a point in an electric field. So this is the point. We are calculating or determining the electric potential of this point. It is defined as the work that we need to do to bring this unit positive charge, 1 unit positive charge, from infinity. Why is it called infinity? Because it is outside the electric field. So if we do some work, so if we give some external energy to bring this unit positive charge towards this to this point, that is called the electric potential. Electric potential is denoted by V. It is also called voltage, and it's a scalar quantity. The potential of a charged body determines the direction of flow of charge when it is brought in contact with another body. Now here is a charged body, there is another charged body, they are brought in contact by a cylindrical wire or conductor. Now how will you know from which side to which side the charge will flow? So if the brown colored particle is a negative charge and the blue colored particle is a positive charge, negative charge is doing the work on the positive charge because the negative charge wants to bring the positive charge towards itself. Thus we can say if there are two charged particles and there is a flow of charge in between them through a metallic wire, so one is negative, another is positive. In that case, we can say negatively charged body loses energy because negatively charged body is giving out energy to pull the positively charged particle towards it. So it is doing work and it is losing energy. And what about the positively charged body? It gains energy because the charge or the energy that this particle is losing, it is giving that energy to this particle. So the positively charged particle is gaining energy. It is very important to understand or to notice who is losing energy and who is gaining energy, because by that we can understand who is doing the work and on whom the work is being done. So work is being done by the negatively charged energy, and that's why we give it a negative sign. So this particle is doing the work, we give it a negative sign, and this particle is the particle upon which the work is being done, so we give it a positive sign as this one is gaining energy. Now negatively charged bodies are said to be at negative potential, or you can just imagine it like the lower potential. Positively charged bodies are said to be at positive potential, or you can think it as higher potential. So in which direction the current or the charge will flow? This direction, from a higher potential to a lower potential, or just we say from a positive potential towards the negative potential. Current always flows from a higher potential. It's not higher actually. In terms of electricity, it is the positive potential towards the negative potential. This is the direction of flow of current. And thus we can say the potential of a charged body, whether it is positive or negative, that determines the direction of the flow of charge or the flow of current when it is brought in contact with another body. Okay, so this is how the charges will flow depending upon the potential and the difference in potentials. Now what is the unit of potential? Unit of potential is volts and it is symbolized by V. Why is it volts? Because another name for potential, electric potential, is voltage. So from that this name comes volt. And what is voltage? What is electric potential? It is the work done. We have seen that voltage is actually the work done to bring a unit positive charge from infinity to a particular place in the electric field. So work done is symbolized by W, and we are bringing a charge. So charge is symbolized by Q, and What about voltage? V equal to W over Q. This shows that voltage is the work done to bring a charge from one place to another. So this is our formula. Voltage equal to work done per unit charge. Now, what about the units? Volts equal to joules over coulomb, because we know the SI unit of work is joule and the SI unit of charge is coulomb. So we can also write it as 1 volt equal to 1 joule over 1 coulomb. This can be written in the terms of physics. We write it as like this: 1 volt equal to 1 J C raised to minus 1. That's the unit and the formula, and that's all about voltage. See you on the next video with a little bit more explanation on voltage and potential difference, and then we are going to do the numericals on voltage, current and charge. See you